Everyone, myself Deepa Singh. Today we will discuss about preformulation, and in this preformulation will include solubilization, different techniques of solubility enhancement methods, and what is the application of solubilization and why we enhance the solubility of particular drug. This is the first unit topic of industrial pharmacy 1 subject of 5th SEM. So let's start. In this, first we know about learning objects. In learning object, before starting this topic, you know about what is solubilization in preformulation study. Why this solubilization is important in preformulation study, partition coefficient, how you enhance the solubility of particular drug with the help of partition coefficient, or what is partition coefficient and why it is important in preformulation. Next is definition of solubility and their mechanism. How solubility helps to enhance or play important role in preformulation and how it takes place, hence mechanism of solubility, different application of solubilization, which field the solubility enhancement is important or solubilization is important, and how the solubilization takes place in different field. In this next is different methods of solubility determination. There's a different method or various method used for determining the solubility. So you should know all these methods. In this, first is definition of solubility study and why you perform this solubility study. In this solution phase and phase equilibrium with solid phase at the start date, temperature and pressure determine amount of drug dissolved and amount of drug available for the absorption. In this, suppose you start solubilizing your compound or your drug at particular temperature, then you check how much drug or how much compound is soluble at particular temperature or pressure. If it reaches its saturation point or a specific point, then you may change temperature, you may increase or decrease. There may no chances always you enhance temperature to increase solubility. In some condition, you also reduce temperature. For certain type of drug that show more solubility in cold condition. So at particular temperature, it shows equilibrium or saturation point, but it have more efficacy to dissolve certain amount of solid or drug also. So you enhance solubility with the help of temperature or with the help of certain pressure. And in this, stability reduction is carried out in certain conditions like enhancement of chemical stability, taste masking product, production of sustained release product. Means enhancement of solubility is why needed, and why you enhance the solubility. Suppose you preparing some formulation and the chemical stability is not good. In this condition, is also you enhance solubility or maybe change solubility. For taste masking product, some formulation, some drugs show more bitter taste and it is difficult to take. In this condition, you use the solubility enhancement technique when you enhance the solubility. So your formulation reduce that bitter taste or maybe mask that particular taste. And the next is production of sustained release product. Production of sustained release product means suppose you're preparing formulation for a long period of a time, like for a month and year, and for controlled release formulation is also. So in this condition, you enhance the solubility so it can appropriate or easily release or solubilize according to sustained release formulation. You can also decrease solubility also. Suppose some drugs are more solubilized or have fast solubilized, but you require less solubilized formulation. In this condition, you reduce the solubility. So not necessary to always enhance the solubility, but you can also reduce the solubility. And next is, this is a method how you perform. The equilibrium solubility is based on the phase solubility technique proposed by Higuchi-Corner. In Higuchi-Corner, you take first drug dispersion in a solvent closed container. Then next is agitated constant temperature using shaker. And next is sample of slurry or withdraw at a function of a time. And clarify the centrifugation assay by HPLC, UV, and GC, etc. This is a technical based method. Otherwise, you can also perform this test at lab scale also. In this, first to take a solvent and solute and in particular container, start shaking with the help of shaker. At particular intervals, suppose 10 minutes, after 30 minutes or 1 hour interval, you take how much sample get dissolved or solubilized in this slurry. With the help of the centrifugation or shaking machine, you take sample and assay with the help of HPLC, UV, and GC. Otherwise, in lab scale technique, just add appropriate solute in a particular solvent and check at particular time or particular temperature, how much drug is solubilized in solution. Next is pKa determination. Solution constant of the drug, and the unionized drug is lipid soluble and these permeate the lipid membrane, and the ionized substance is lipid insoluble, therefore formation is slow. There is some condition where hydrophilic drugs are more easily permeate or solubilize the membrane compared to a hydrophobic drug, and this pKa dissociation constant is play important role for this solubility or maybe the solubility factor. Suppose your drug is an ionized drug and lipid soluble in nature, then permeates through lipid membrane because it's a lipid soluble and oil soluble, but in an ionized form. So it should more solubility or easily cross the membrane. And similarly, opposite for ionized substance. Suppose your compounds are in ionized state and lipids insoluble, therefore permeation is slow because it's not in a lipid soluble or in oil soluble, it's a hydrophilic in nature or lipid insoluble, as well as in an ionized form. So it show less permeation or maybe no permeation of the membrane. This is a degree of ionization depend on the pH. pH is also important, and this pH you calculate according to type of the compound, maybe it's a basic compound or maybe acidic compound. Both have a different equation. For basic compound, you calculate with the help of Hasselbalch equation, and for acidic, you also use same Hasselbalch equation. For basic, it's a formula is pH is equals to pKa plus ionized divided by unionized. For acidic compound, it's just opposite or vice versa. pH is equals to pKa plus unionized divided by ionized. Means in for basic compound, you divide ionized to unionized form, and for acidic compound, you divide unionized drug to ionized drug. And how you calculate percent ionized amount? For percent ionized amount is equals to tan pH minus pKa divided by 1 plus tan pH minus pKa. And determination by UV spectroscopy, potentiometric titration, and titrometric method. These are the methods in the help in this techniques or by the spectroscopy or potentiometric titrometric titration method. You calculate the pKa value or maybe how much solubility according to type of weak base or weak acid. Next is solubilization. In solubilization, it is defined as spontaneous passage of a poorly water-soluble solute molecule in the aqueous solution of a soap or detergent in which thermodynamically stable solution is formed. In this process, thermodynamic processes takes place. Suppose you solubilize a particular drug or particular solute with poorly water-soluble molecule or aqueous solution, there may be some chances which show less solubility. But when you dissolve with the help of soap or some detergent or with the help of some surfactant, it shows more solubility. So when you solubilize or dissolve any type of the drug with the help of certain excipient with certain technique, or it enhances the solubility, it is also known as solubilization. In the solubilization process, by apparent solubility of an otherwise primarily soluble substance is increased by presence of surfactant mixture. And when your drug is having less solubility or is partially solubility, then when you add surfactant or soap or detergent solution, it easily solubilize and solubility of particular drug is increased. Or these drugs may be poorly soluble, but when you use surfactant, it enhances the solubility and it show more release or more fast solubilized substance. This process is mainly takes place with the help of surfactant, and this process is also known as micellization because in this process micelle is formed. Now we know about what is micelle. Micelle is the mechanism involved in property of a surface active agent to form a colloid aggregate known as micelle. When you add surfactant, and it start forming aggregate or some large mass like aggregate formation. So this aggregate formation start and it form more aggregate and start forming micelle. This is known as micelle, and means micelle is the involve property of a surface active agent. Without surface active agent or without surfactant, micelle formation is not possible and won't take place. And the next is when surfactant are added to liquid at low concentration, they tend to orientate at air-liquid interface. This micelle formation or solubilization is also dependent on the how much surfactant you use. Suppose you're using less surfactant or concentration is very less, so it do not start forming micelle. It just interface or maybe float on the surface of air-liquid interface or at particular solution. and it may be enhanced solubility, but very little amount of solubility enhanced due to the less amount of surfactant we use. And missile formation is also not takes place. There may be some chances that your surfactant get interacted and form under the orient in air liquid interface. And on further addition of surfactant, the interface becomes completely occupied and excess molecule are forced in the bulk of the liquid. But you subsequently adding more surfactant or enhancing the concentration of surfactant. In this condition, interface will get completely occupied with surface active agent, and excessive molecules start forming bulk mass or missile-like structure. Means when you add a small surfactant, there is no effect, only it orient or may float on the surface, liquid interface. But when you add more surfactant, it occupies complete surface or excess surface and start forming bulk mass. At very high concentration, surfactant molecule in the bulk of a liquid begin to form a missile, and this concentration is known as critical micellar concentration or CMC. At particular high concentration or very high concentration, molecule form bulk liquid or bulk mass or bulk missile. This is known as critical micellar concentration. And this amount of surfactant or this concentration is known as critical micellar concentration or CMC. In this point, you use large amount of surfactant or surface active agents. In this point is missile formation will start, and this is also known as CMC. And the solubilization is through to occur by virtue of solute dissolving being absorbed on the missile, and your the solute or drug get absorbed with the help of missile, and it interacted with missile, and the ability of surfactant solution to dissolve or solubilize water in soluble material. With the help of this surfactant or surfactant active agent have the ability to dissolve insoluble material also, water soluble material also, and start at CMC and increase the concentration of missile. Due to solubility enhancing start or when you increase concentration of surfactant, CMC formation is also increased, or critical micellar concentration is also increased due to enhancement of surface active agent. It's more the surface active agent, more this missile form or more micellar concentration is increased, and concentration of missile is large, and this large amount of missile has to enhance the solubility of particular drug. Next is solubilization of any material in any solvent on proper selection of solubilizing agent. This solubilization is mainly dependent on the type of selecting active agent or surfactant, which type of surfactant you use, or which type of solvent you use for particular method of particular solubilization. So this is all depend on the type of solid and type of solvent. Next is process of solubilization, how this solubilization takes place. In the solubilization process, it's divided into different steps or different parts. First is process of solubilization involves the breaking of inter-ionic or intramolecular bond in the solute, and the separation of molecule of the solvent to provide space in the solvent for solute interaction between the solvent and solid molecule ion. Means when you use the surface active agent or solubilization process is involved, breaking of inter-ionic or intermolecule between the molecule or between the ion, there is some bond and start breaking in a solute. This process is mainly for solid particle, not for solvent. When you take suppose certain drug or certain solid molecule, so when you adding this solubilization process or adding surfactants, it may be chances there are some non-ionic or intermolecular inter-ionic bond gets break, and due to this breaking of ions of molecule, so such separation of a molecule of a solvent provides a space in the solvent. When this molecule gets break, there may be some chances space is formed, and due to this space interaction between the solvent and solid molecule or ion. When this break gets break and bonds are get break, there may be chances some space are formed or some more space are present between this bond. So in this condition, your solvent get interacted and form the good molecule, and due to this interaction between the solid and solvent, solubility get enhances. In this step of process of solubilization, first step is holes open in the solvent. Holes open in the solvent means when you take a solid or your drug and you add surfactant, due to this there may be some chances intermolecular or inter-ionic bonds get break, and you can see that in this image these red holes get occupied more space or randomly arranged. In first image, there may be closely to each other, but in this, there's so many space between this molecule or between these particles. In this first step means holes are open in the solvent. Next step 2 is molecule of a solid break away from the bulk. And this is a solid molecule, and in the solid molecule, when you add surfactant, there may be breakage of bond or this space is also formed. You can see this image in. And third step is the free solid molecule is integrated in the solvent. Means after forming space with solid and solvent, it get interacted and form the final good solubility product. Because this solid and solvent get occupied space present between you, and this space is from good missile or good product which show more solubility compared to previous one. Next is definition of solubility. In this definition of solubility, the amount of substance that passes in the solution in order to establish equilibrium at a constant temperature and pressure to produce saturated solution. Solubility means substance that passes in the solution in order to establish equilibrium at constant temperature and pressure to produce saturated solution. Means when you adding start some drug in particular solution, it is easily solubilized, but you require more solubility or more compound or drug gets solubilized in particular solvent. When you change certain temperature or pressure, due to this temperature and pressure, the solubility showing more or saturation showing more. Suppose 100 gram sugar dissolved in 200 gram water at room temperature, but you require more sugar dissolved in 200 gram or 200 ml water. Then you change temperature, pressure of that particular solvent. Maybe you start heating that particular water. So due to this changing temperature and pressure, it may be chances up to 150 gram sugar may be dissolved in particular water. So this temperature and pressure changes is also very important factor enhancing the solubility. When you change temperature and pressure, then the chances more compound or more drug gets solubilized in particular solvent. Not only surface active agent is responsible for enhancing the solubility or changing the solubility, but certain if solubility is less than 1 mg per ml, indicate place to for more salt formation to improve solubility. Suppose you use 1 mg or less than 1 mg drug in 1 ml. So in this condition, it indicates need for salt formation. If improved solubility, you should improve solubility in this condition. When you use less than 1 mg up to 1 mg, your drug in particular 1 ml solution or maybe in a solvent. Next condition, if the solubility is less than 1 mg per ml in pH 1 to 7, preformulation study should be initiated. When concentration is same, we just change the pH level. pH is 1 to 7 means in acidic condition pH. Suppose you take 5 pH and your compound is less than or maybe up to 1 ml, 1 mg in 1 ml solvent. Then in this condition, you should be say that preformulation study should be initiated. And solubility should be ideally be measured at a temperature 4 degrees Celsius to 37 degrees Celsius. This is the initial temperature where we check solubility. This is a normal temperature, but if it's not solubilized in this particular temperature, then maybe you enhance or decrease soluble temperature according to your requirement. And in 4% degree Celsius to assure the physical stability. When you dissolve your compound in 4 degrees Celsius, it shows it's a physical stability assurity. But you dissolve in 37 degrees Celsius temperature to support biopharmaceutical balance. Because our body temperature is also 37, when you check solubility at 37 degrees Celsius temperature. So it is showing good result in biopharmaceutical factors or biopharmaceutical evaluation. Means the ADN parameter is also good because 37 degrees Celsius is normally body temperature, and when you check solubility in 37 degrees Celsius means you just consider this formulation in according to body requirement and body temperature. So your biopharmaceutical evaluation gives good rating at 37 degrees Celsius. Next is this is a different type of solubility according to parts or how much their solid dissolve in particular solvent. In this first is very soluble means less than 1 part. Second is freely soluble means 1 to 10 parts, and soluble means 10 to 30 parts, and sparingly soluble is 30 to 100 parts, and slightly soluble is 100 to 1000 parts, and very slightly soluble means 1000 to 10,000 parts, but insoluble means more than 10,000 parts. So you should be select according to this amount or according to this part which type of solubility is required. If your drug is very soluble or freely soluble or maybe soluble, then it indicated it should be less than 1 to 30 parts. But if insoluble form, then it's more than 10,000 parts. So these are the readings. These are the specific standard readings according to certain pharmacopoeias. Next is solubility enhancement. How you enhance or analyze this solubility. There is different technique for analysis of solubility. And in this preformulation step, solubility study focuses on the drug solvent system that could occur during the delivery of the drug candidate. And example drug for oral administration should be examined by solubility in a media having isotropic chloride ion concentration, acidic pH. And this solubility analysis is checked with the help of certain technique, and this technique is mainly dependent on which formulation you use or which type of drug administration do you use, and also pH media, acidic condition or basic condition. And in this condition, drug solvent or drug soluble molecule is also responsible for analysis of solubility. Analytical methods that are particularly used for solubility measurements include HPLC, high performance liquid chromatography, UV spectroscopy, fluorescence spectroscopy, and gas chromatography. These are the techniques which mainly used for checking the solubility method or solubility analysis. And these are the instrument-based methods. Other than these, some laboratory methods are also used. You can use according to your formulation, according to your condition, which condition you have available. And in reverse phase HPLC offer accurate and efficient means of collecting solubility data of the drug. But when you use reverse phase HPLC, it is more efficient and more good collecting data and more relevant data for solubility compared to a normal HPLC. Instead of HPLC, you can also use reverse phase HPLC technique or reverse phase HPLC because it's more good compared to HPLC technique. Next is pH solubility profile. In pH solubility profile, the solubility of acidic and basic drug will show difference in solubility with pH change, and pH solubility profile of drug can be established by running the equilibrium solubility experiment in the pH range of 3 to 4. Means this solubility enhancement or solubility is not only dependent on temperature and pressure change, but it is also depending on the pH range, which pH you use or which pH solvent you use for this solubility. And the solubility of acidic or basic drug show difference in solubility change in pH. When your pH range is different, maybe acidic or basic, then in this condition solubility is also vary. And the pH solubility profile of drug established running equilibrium solubility experiment in the pH range 3 to 4. Mainly this testing is this between the pH range 3 to 4. This is only condition for acidic, but in these conditions also change according to the requirement. So according to pH, solubility is also decrease or maybe increase. This partition coefficient. In partition coefficient, it is a ratio of unionized drug distributed between the organic and aqueous phase, and it's a formula for partition coefficient is OW, oil in water, is equals to concentration in oil divided by concentration in water. This is an equilibrium condition. This partition coefficient may be used for determining the drug is how much soluble in water, how much soluble in oil, and which type of your drug, maybe an oil soluble, hydrophilic, or any lipophilic drug. And you can calculate this partition coefficient with the help of this formula: concentration in oil divided by concentration in water. This is a ratio of partition coefficient in oil and water phase. And according to this formula, by this formula, you can check how much drug is solubilized in oil or maybe in a water. And this technique is very easy. You can perform this technique in a lab also, because you just require oil phase and water phase, and you in this technique first to take your any type of container, maybe conical or maybe any other container, and add some oil and water and shake this container And after checking particular time, maybe half an hour or 20 minutes, you check how much drug gets solubilized in a water phase or in a oil phase. And this reading calculate with the help of certain equipment or certain machines or titration also. And it's a very simple method. Effect of temperature. And effect of temperature is the heat of solution, HS represents the heat of release and absorb when a mole of solute is dissolved in large quantity of a solvent. Heat change in temperature, effect of the temperature is mainly dependent on the heat of the solution, HS. And this is mainly also depend on how heat is absorbed or released from particular moles of the solute, particular solvent. And it is also divided into two types, endothermic and exothermic reaction. And this is exothermic and endothermic depend on the how much drug is absorbed or maybe released. The solvent and solute must be pure. It do not contain any impurity or any foreign particle. It should be in a pure form and do not contain any contaminated other material. Both solid and solvent means your solvent as well as your drug or any other compound should be in a pure form. And a saturated solution must be obtained before any solution is removed for analysis. Before withdrawing sample or before analyzing the sample, you should assure that your saturation is reached or your solution is a complete equilibrium condition. When you don't check the saturation solution saturation point, then there are some chances you get interactive readings or don't show any good result or there's some error in the results. So before start checking the solubility, first you assure that your solute and solvent should be in a pure form. Second is it should be in a saturated point. And next is the method of separating a sample of saturated solution from and dissolved solute must be satisfactory. Suppose the saturation is reached, but still in solvent there is some solute molecule which is not solubilized, but saturation is reached. In this condition, we assure that how much solute is present in particular solvent or particular solution, so that you can just compare how much solute you added in particular solvent and how much is dissolved and how much still present in undissolved condition. So, calculating this readings or analyzing this reading, assure that how much is dissolved and how much is present in undissolved form. Next is method of analyzing solution must be reliable. Which method you use, and this method is appropriate or good for your condition or good for your formulation. You should know that all these things. Temperature must be adequately controlled. Which temperature you use for this solubilizing? It should be controlled manner. Don't enhance or reduce directly. Just note it down that already how much gram, how much ml particular solute is dissolved in particular solvent, and when you enhance or maybe decrease the temperature, so it affect or not in particular solute. All these parameters checked before starting or analyzing the solubility. In this, you can also check solubility is normally depend on the temperature. So temperature is reported in each solubility measurement. Suppose you adding 10 or maybe 1 gram at particular temperature at particular interval of a time. So you can just note it down. This reading or these records are according to solubility range. So you can just differentiate how much drug is dissolved in particular temperature or particular time. Next is plot of solubility against temperature, is commonly used for solubility determination. Plot of solubility against temperature is used for plotting the graph of solubility, how you check solubility. So you just plot solubility versus temperature, how much drug is solubilized at particular temperature. These are the two methods which used for analysis of solubility. First is analytical method, second is synthetic method. Both methods you use according to different type of formulation. And in this analytical method, temperature of equilibrium is fixed and concentration of the solute in the saturation solution is determined at equilibrium for suitable analytical process. In analytical means the temperature is fixed. Suppose you set particular temperature, 37 degree or maybe 42 degree, any temperature set, and concentration of the solute is saturated solution. Just the fixed solute amount or how much solute is present in particular condition, and with the help of this fixed amount of temperature and solute to determine how much drug is solubilized, or with the help of certain analytical method or equipment, you just analyze how much drug dissolve at particular condition. Next is, in other hand, was saturated solution in presence of excessive of undissolved solute in a present and accurately known temperature, and saturation can be achieved by suitable contact between the solute and solvent. In this condition, we also know that if your drug is not completely dissolved, you just add excess amount of a solute in particular solvent, but still there is some insoluble material is present. In this condition, assure that how much it present and at which temperature it reaches to saturation. All this condition you at least know before completing this reading or before analyzing this reading. Means first you know which temperature you use or which temperature you enhancing, just record down all this reading, and also that which temperature it reaches to equilibrium condition, and also how much drug or how much solute you dissolve in particular solvent. All these conditions are required for recording this solubility technique or solubility amount. This is about all analytical method. The next method is synthetic method. In synthetic method, in this process method is weigh amount of solute is placed in the vessel. Similarly, in this condition, you also first weigh solute or how much drug you take. You just weigh in a vessel and put in particular vessel or in a container. After weighing, while agitating the system at a constant temperature, known amount of solvent is added gradually until the solubility limit is reached. And equilibrium temperature and content of synthetic is also recorded. The method is carried out at macro scale level by examining small amount of system under the hot stage microscopy. So we can just differentiate these two, analytical and synthetic technique. Means in analytical technique, you just set prior all solute concentration, temperature, all these conditions. But in synthetic condition, you just feed specific amount of solute and gradually add the solute in a solvent. Not directly complete solute you add in the solution, but in analytical method you add complete solution and just end of the practical or end of the this testing you check how much in the undissolved form or how much is get dissolved. But in synthetic condition you just gradually add how much you added and at which point your equilibrium or saturation point is reached, and also record the temperature. And this synthetic method is mainly for small scale or for lab scale. You just check small amount of compound or solute by using this synthetic method. Next is application part of the solubilization. Which field solubilization is used or why solubilize is necessary. In the application of solubilization, first is drug with limited active solubility can be solubilized. This include oil soluble vitamins, steroids, hormones, antimicrobial agents. Means some drug or some compound which have an active solubility or limited active solubility. So in this condition, you use the solubilization method or enhance the solubility. For example, oil soluble vitamins, steroids, hormones, and antimicrobial agents. Some antimicrobial drugs, vitamins, which are oil soluble in nature, and steroid formulation or some steroid hormonal formulation is also enhance the solubility by the help of solubilization. And due to their some insolubility property or chlorine soluble property. Next is solubilization of orally administered drug. It can be improved appearance and improved unpleasant taste. Suppose you're formulating tablet or capsule or some oral dosage form, but your drug should be bitter in taste or not good in taste, and so unpleasant appearance. So in this condition, when you enhance the solubility or improve the solubility, this taste is overcome, and you can improve the or maybe appearance and formulate good quality formulation. So some appearance changing or unpleasant taste improving, you also use the solubilization method. Next is both oil, water, and water soluble compound can be combined in a single phase system in case of multivitamin preparation. Suppose you're preparing both formulation or both type of formulation, oil soluble as well as water soluble compound in a combination. You're taking two type of drug. One is soluble in water and second one is soluble in oil. In this condition, the formulation may be difficult to formulate. If it's formulated, then it may show some solubility issue. In this condition, solubilization technique is used for single phase or for single formulation, because oil and water don't get mixed or don't miscible to each other. But when you use solubilization technique, both oil and water soluble drug get mixed and form a single phase. This is mainly for multivitamin preparation. Means this technique is mainly used for multivitamin preparation. Suppose you're taking oil soluble vitamin as well as water soluble vitamin, but they don't get dissolved. In this condition, you use solubilization. So both oil soluble and water soluble vitamin gets from single mixture or single solution, single phase solution. In next application, solubilization may lead to enhance the absorption and increase biological activity. Suppose you require more absorption or fast absorption, or showing more increased biological activity, mainly for fast disintegrating tablet or fast release tablet. In this condition, you also use this solubilization technique, because when you enhance the solubility, then the chance of absorption rate is also increased and biological response is also increased. So you can change this absorption rate and biological activity with the help of solubilization technique. Next is improve the institutional absorption of vitamin. Means vitamin A formulation are not easily absorbed in intestine. It shows some error or maybe partially or not properly absorbed in intestine. So in this condition, you use solubilization technique. When you use the solubilization technique, vitamin A formulation easily get absorbed in the intestine and show good absorption rate or more absorption. Next is drug absorption from ointment base and suppository also increase. Suppose you're preparing some ointment or some suppositories, and due to the particular base, absorption rate may be affect or do not absorb properly or do not permeate to the particular membrane. So in this condition, you use this solubilization method. When you use the solubilization method, suppository enhance their solubility or absorption rate, as well as ointment is also properly absorbed and their bases change their property. We do this base change property, absorption should move fast in ointment case. Next is liquid preparation. A small quantity of preservative can be prepared by solubilization. Suppose in some liquid formulation, there's no need of preservative, a small quantity of preservative is used. But when you use less quantity of preservative or no preservative, then some chances it may degrade. This condition you also use solubilization technique. And liquid preparation, use small preservative or reduce the concentration of preservative with the help of solubilization technique. This is all about enhancing the liquid formulation solubility or solubilizing property. This is all about different types of solubilization or how you enhance the solubility, different analytical methods. So today's lecture we discuss all these things, means how you enhance the solubility or which technique you use for determining the solubilization, or which parameter is necessary when you performing this solubility study, and how you avoid this some conditions like when you take improper or impure solvent or solute, maybe their readings change or show some changes. So you use proper condition during performing this solubility analysis. Or there's two methods, analytical method and synthetic method, and which industry use the solubilization technique, and the solubilization technique, temperature and pH, how it affect, all this covered in this lecture. So this is the reference. First one is Ansel pharmaceutical dosage form drug delivery system, 8th edition by Lord B. Wellen Nicholas, chief of which Howard C. Ansel, published by BA Publication PV Limited. Page number is 187, 193, 42, 43. And 126 to 133. Next is pharmaceutical preformulation by J.T. Partition, published by Technical Publishing. For page number is 126 to 112 to 112. Next, third one is textbook of physical pharmaceutical by CBSE Subramaniam, published by Balla Prakashan. Page number is 18202 and 22 to 26. And next is theory and practice of industrial pharmacy by Leon and Yakman, Harris, Lieberman, Joseph, and King, first edition, published by Bangalore Publishing House. Page number is 171 to 184. And the pharmaceutical dosage form tablet, volume 1, edited by Harvard's Lieberman and Leon Leishman, published by Marshall Decker. Page number 1 to 10. Next is Martin Physical Pharmacy and Pharmaceutical Science, 5th edition by Patrick J. SinghSchool, published by Liverford William. Page number 547 to 5. All these are the good book and have good content. Other than this book, we also use any other book, but these are the sufficient for this particular topic. And this is all about solubility. And these are the questions for this topic. First one is a non-crystalline form that is often more soluble than a corresponding crystal form. In this option, A is dissolution, B is solubility, C is co-solvent, and D is amorphous. And second question is solubility of unionized parent compound have an option optical counting method, B is equilibrium solubility method, C is intrinsic solubility method, and D is organoleptic property. And third question, the presence of the co-solvent have increased the solubility of hydrophobic organic chemicals. And the option, first option is co-solvent effect, B option is dissolution, C1 is capillary melting method, and D is organoleptic property. And in fourth question, which property measures the resistance of liquid to the fluid? In this, density, maybe viscosity, C1 is volume, and D is the solubility. Next, in this, you explain which property is resistance to liquid flow. Next is what is the liquid definition of is a liquid which become a less viscous as the rate of shear increase. In the option is a liquid which become more viscous as the rate of shear is increase. C1 is a liquid which become less viscous over the time as a constant shear stress is applied. And the option is a liquid which become more viscous over the time when a constant shear stress is applied. And C option, what is the correct definition of the solubility is a 6-1 question. In this A option, the ability of a solid particle to disperse throughout a liquid continuous phase, and B1 is the ability of the solid to dissolve into a solvent. And C option is the rate at which solid dissolve in the solvent, and D option is the ability of immiscible liquid droplet to disperse within a second phase or liquid phase. Next, 7th question is the rate at drug become available in the organism. The rate limiting step in the absorption is A option is co-solvent effect, B option is optical counting method, C option is solubility, and D option is dissolution. And 8th question is the weak base increase pH result in solubility. A option is increase, B option is decrease, C option means solubility change, and A is solubility, dissolution rate. This is all about weak base. And you select out of this ABCD option which one is appropriate. Next, 9th question is preformulation is about assuring only safety, only stability, only efficacy, and last is all safety, efficacy, and stability means all A, B, C, D. So in this, you know about what is preformulation and which assurity gives this preformulation. According to this, you select any one option. And 10th one is last one is what is the role of xanthan within some liquid formulation, regulate pH, control viscosity, enhance solubility, enhance viscosity. This is regarding the xanthan gum. You select A, B, C, D out of this 4 option, any one option. This is all about question part. So thank you everyone. Thank you so much for listening and watching this video. Thank you. And next lecture we discuss another topic. Thank you.